Welcome to the Impulse Spotlight, a podcast for product development professionals. In this episode, we speak with the engineering manager at FHE and discuss the Riglock 2.0, a product used in the oilfield industry to improve safety and boost productivity. Our guest is an avid inventor, spending his winters in his garage 3D printing functional products and printing parts to make an upgrade to 3D printers. Summers, on the other hand, are enjoyed at the lake with his family. Mathew Kibler began his engineering career in 1996 working in a laboratory where he developed multi-axis titration dispensing robots. These early innovations in laboratory automation may have inspired the 3D printing technology we see today. In 2002, Mathew transitioned to the product packaging industry, joining a company where he spent 15 years developing a high-speed folder gluer, packers, and flame sealers. His journey from draftsman to CAD Manager to lead design engineer underscores his expertise and dedication to engineering excellence. In 2017, Mathew brought his wealth of experience to FHE, where he began as the sole design engineer. Through his leadership and vision, he built and expanded the engineering team, becoming the engineering manager in 2023. Today, we dive into the design process of the Riglock 2.0, exploring its features and the challenges faced in development. Mathew shares insights into the product development timeline, the impact of technology on the process, and the importance of safety and validation in product design. We'll also discuss the trends in product development, strategies for improving product development timelines, the importance of having a strong understanding of the tools you use, and where that can take you. Mathew has plenty of experience and wisdom to share, so let's get into it. Hey, Mathew, welcome to the show.
Hey, Troy, thanks for having me.
Yeah. So I've been started Impulse 25 years ago. Worked for another product development company, saw the writing on the wall that they weren't going to be around much longer, and started Impulse and have been designing products for other companies since. How did you get into product development?
Product developments for me started right out of high school. When I was a senior in high school, ended up in the technical trade school, got my CAD degree, and my first real CAD job, I fell into a great company that I was able to start developing and designing products as a very, very young engineer.
Very cool. And so what's your current role and what kind of products do you develop?
Currently, I'm engineering manager for a company called FHE. We develop products for the oil and gas industry, so primarily pressure control equipment and more recently latching devices. So we developed the original Riglock, which is kind of the Kleenex of the industry when it comes to latching devices, and then we evolved to what we call our Riglock product, which is more of a fracking operation rather than the pressure control and wireline operations. And more recently, we'll talk about the product today, which is Riglock 2.0.
Before we get into the Riglock 2.0, for me and other people that don't understand all of that, what's the locking device and what does it do?
In the fracking industry, what they do is it's called plug and perf. So they will load up a string of detonators and they will pump them down hole. They will plug off the location and then they will shoot off those detonators, which fractures the formation, and then they will pull that entire gun string out. And our device, what we do is we lock and we unlock at the time of breaking and making the connection so that they can send those guns down hole and do their perfing. And then the frac side of the equation comes in and they pump sand and water and chemicals and some things down hole. That then expands the formation to get to the oil and gas that we use every day for all of our energy use.
Okay. So like to keep it real simple, is it like a cap that goes on top of the hole?
It's like a hydraulic or a pneumatic air connection for a very, very large pipe. So 5-inch pipe pneumatic air connection or hydraulic connector.
Interesting. All right. Yeah. So
go ahead.
No, go ahead.
I was gonna say we do ours with, it's all hydraulically driven, so hydraulically controlled. With the first Riglock had cams that locked the stinger in position. The current generation has a wedge-like or a dog-like gripper system with, backed up by what we call a lock ring that keeps all the stresses into a very, very controlled environment so that when the pressure is on the system, we know we have safe, controlled connection at all times. And then our automated system, the new automated system goes in, and every time you break and make that connection, our automated system actually does a pressure test for seal integrity automatically, and then gives you a graph that tells you how long and what pressures you're at, and then you can share that with whomever you need to get final approval to make sure that the next process in line goes smoothly.
Okay. All right. And this is the Riglock 2.0?
That's correct.
Okay. You may have just said this, but just for my benefit, what were the big changes between the original and the new one? I want to get into a little more detail on the actual product.
Sure. The original model was designed for pressures in the range of 10,000 psi working pressure and a test pressure of 1.5 times that of 15,000 psi. We did do an upgraded modification to get them to 12,500 psi. Which is being used every day in the field. Many, many, many units out there being used. One of the major differences for this design was we went ahead and made it a full 15K unit. So it can work on not only existing wells and 12.5K wells, but even future locations that may require a 15K connection. The other major difference is our original Riglock, the locking mechanism pointed up, and the female, sort of the receptacle part of it, receiving the stinger, was on each of the wellheads. So when they do these operations, they have sometimes up to 12 or 20 wellheads on location. And so you would order a package and have, four or five or 8 or however many you needed of the latching devices, and then one stinger. The main difference here is now we put the latching device and the stinger in the on the end of the crane, and so we swing around and we latch on with the male and the latching device, and now we just supply multiple adapters that go on top of the wellhead, female adapters, and the benefit to that is you don't have quite as much equipment out on location. You don't have as much weight. You don't have your HSE when you're getting back and forth on locations. All those things are minimized in this case.
Okay. Is it, how do I want to ask the question? How does the new product benefit the user? I mean, is it improved in that way that it's easier on the user?
Oh yeah. Significantly. We've effectively automated the process. So in our first generation, we had a control panel with several valves and controls and levers and gauges, and you kind of had to be a master mechanic to kind of work the operations of the whole thing. And then not only is there an operations panel for one, but there's an operations panel for 4 of them, and so you're not sure which one to even touch, which knob to grab, which gauge to look at. So it got a little intimidating, and with the changeover in the personnel that are on locations, the training that has to go in to teach these people how to use them correctly, safely, it can be a challenge. Obviously they're working every day and very successful. But what we did was made this version much more user-friendly, where honestly it's a push of a button and everything happens in the system automatically. All of the safety checks are done. All of the pressure tests are automatically controlled. All of the indicators that need to be triggered. All of those happen in the background. The user doesn't even have to worry about it. He gets a signal that says, good, you're good to go. You got your pressure test success. You got your latching is success. Gets a big green light. And on the control unit, which is, very visible from location, everybody knows, hey, we're green, we're good to go, and we can go down hole. That's all done with one push of a button to latch it, one push of a button to unlatch it. All that automation happens in the background, and our system is literally one button push.
So it's safer, faster.
Way safer, way faster. We're at I think a minute and a half from stab to lock, and about 45 seconds to come off. And that's most of that time is just safety redundancies and just making sure that we are safe to detach or safe to be pressured up on.
So we've helped design literally thousands of products, and every one of those journeys is a little bit different. So can you kind of walk us through the journey of developing this product? What were the steps involved?
Yeah, the steps are really, you got to have a vision for what you're looking for. I'll just introduce a couple of my teammates. Nick Snoke is the president of FHE, and Steve Hutchinson is our product development specialist. So the three of us get together. We sort of scheme up what's the next thing we're gonna work on, and then we develop the vision for what that product needs to be, how it needs to interact with the field, what maybe what the customers are giving us feedback on over the years for other products, and we just take all of that information and then we come up with a strategy for what the latching mechanism is going to look like, whether it's going to be on the wellheads or if it's going to be hung, if it's going to be standing up. How we want to interact with it, how the field personnel need to interact with it, what pressure rating it's going to be at. And so we set that sort of scope in our minds, and then I typically go back and start a mechanical design of some sort, of trying to optimize and think about serviceability, so our service departments can get through and service these quickly, tear down, recertify, rebuild, and have all that as efficient as possible. So a lot of the process for this design was really thinking about and designing for serviceability, and obviously with function and stress analysis and safety always forefront in our design cycles. Then manufacturability. So after we go through the design cycle of serviceability, do several design reviews on, hey, what do you think of this? What do you think of that? Steve's fundamental in giving feedback from a field perspective and the user's perspective, which is always fantastic feedback. And then also how it's going to interact with the environment. So oftentimes we get back units that are just greasy and gross, and they have to be serviced, and so in this design cycle we spent a lot of time thinking about how we can prevent that grease ingress into the mechanism and into the workings of the system. And so we designed this to be contained rather than sort of exposed to the elements. That feedback was fantastic. Also, the seals that we use, we evolved those seals from field trials that we've done for the past several years. And then the controls. So Steve's our controls expert, and we work very closely together on how the interaction from the sensors and what sensors we should use, how many sensors we need. We've got bore pressure sensors, we've got position sensors, and we've got some redundant switches in there, and all that has to be coordinated. And then the programming for the HMI, we work closely together on all of that. And he's got a team that works on those as well. And then We sort of parallel the designs, so the control system's kind of being in parallel with the mechanical design, and then get to a prototype phase, build a prototype, test it. We did a little road show this year, kind of getting the buzz a little bit down in Texas, and we were able to show it off to our customers. And while we were doing this, it was kind of a pre-prototype testing phase. We were able to see how it was working, if there was any things that we wanted to change, which we did. We changed a few things, several things actually. Changed them for reliability, changed them for function. It was good. It was actually really a good field trial, even though we didn't put any pressure on the system at all.
Okay. I was going to ask about your prototyping process. Is that like, do you do 3D printed stuff early to test mechanisms, and then do you get into like actual metal prototypes that you can field test, or what does that process look like?
Yeah, a little of both. So hobbyist 3D printer. Myself, I've got a few of them in my house, got a few of them at the office. So yeah, when I come up with an idea that I like and I think, all right, I think this is going to work, I'll go ahead and print a sample, either scaled or full size, and kind of articulate it, maybe put it on my desk, look at it for a couple of days and kind of just feel it out, see if I really like it, pass it around the office, in the development team, and poke holes in it. Like I give these guys things to poke holes in so that by the time we do go to metal, we are generally, I wouldn't say one and done, but we are very, very close to a functional device by the time we go to metal. I've been doing this for almost 30 years now, designing mechanical pieces of equipment that have been built by fabricators and machinists. Worked very, very closely with machine shop for my previous job for almost 15 years. So I've got a pretty good feel for getting things done the first time, and well. Arguably, my tolerancing is sometimes a little suspect. I do get some pushback. I tend to be fairly aggressive in tolerancing for the prototype, and then start backing numbers down as we work through and see if there's anything that maybe is not moving as intended, or maybe has a little too much resistance. Sometimes it doesn't go together, and you gotta massage it a little bit. So generally, by the time machine shop prints are done, the design's pretty well done. I don't do a full prototype, 3D printed prototype, functional prototype. I've never done that. Do a lot of FEA. So before we ever put anything to metal, we're very validated and verified that the FEAs are accurate, that there's no stresses that we're concerned about. Go through all the metallurgy and make sure that we're happy with the selections of metals, and for cost purposes, because you can always go exotic, but you don't want to. You want to go with the most common components that are out there. So we try to stick with the most common oil and gas industry known materials, so that we don't have to go exotic.
Sure. So, but it sounds like you will do one final metal prototype before you go into full production.
Oh yeah. Yeah, we'll do one metal prototype. Like I said, we'll function test it, we'll cycle test it, we'll beat it up, test it. I like to just say, all right, go break it, and then tell me what broke, and then we'll go fix it. That's kind of a good way to. I actually don't like being involved in that, because I don't want to see how they broke it. I just want to know what broke, and then kind of fix it from there if we have to.
Sure. Are most of the parts machined or cast or both?
Yeah, almost everything's machined. So forged bodies, and then turned. My designs are generally a lathed product that then has some millwork on it.
Okay. So your prototype is literally just like the production version. It's just not on a production.
Yeah. Our prototypes are in the field running to date, today. We're over 240 cycles as of this call, and still going strong.
So the from a manufacturing standpoint, is everything done in house? Is it outsourced somewhere in the States, or?
Yeah, so at
Okay.
FHE, we do almost everything in the United States. Um, we source from many machine shops locally, and then we've got some regional machine shops in Texas and then in the Midwest. So they will manufacture all of our hardware, deliver it, and then we assemble, test, and validate in-house. But we do
Okay.
not have any in-house machine shop capabilities at this time. We do have a fabrication department, so our fabrication department makes the control units and the control skids and the equipment that all the equipment that goes with the controls, but the structural equipment gets manufactured outside
Okay.
or machined outside and then
Yeah.
assembled here.
Interesting. What's the timeline look like for developing something like that?
That's a tricky question. From I'm going to say from the time we have a prime path to the time we get a prototype is roughly 6 months.
Okay.
Now, to get to prime path can be a very large variable. And I say that people may not know what that means. Prime path is an accepted direction that everybody agrees, yes, this is the direction we want to head. As a developer, I'm going to go through 3 or 4 or 5 different design iterations that maybe aren't that I don't get buy off.
Hmm.
I don't get acceptance for. Maybe they're just so crazy and so far out there that they don't need to be built. They don't need to be brought to the world. Other times we will take a design to a certain point and then take a step back and look at it and ask ourselves some of the fundamental questions of, is it sealed properly? Is it going to shed water properly? Is it going to keep out dirt? Is it, and so those type of questions can significantly alter a design, even though you've put maybe a month worth of design time into it.
Hmm.
But usually once we get to prime path, it's a fairly quick, I say fairly quick, 6 months to a prototype where all the finalized designs, all of the FEA, all of the drawings, and then the machining time, which is, on a brand new one, is anywhere from 4 to 10 weeks, just depending on how complicated the part is, and then you got to get the machine shop spooled up, and so there's a lot of things that go into that 6 months. But that's a for me so far that's been a pretty common timeline.
Okay. And then after that 6 months, you'll start testing.
Yeah, yeah. Testing, validating. Then there's usually a short design cycle for revisions. This time we did a moderately complicated redesign, and it was just the way that the hydraulic cylinders were designed. I made them easier to install and more efficient and more compact overall.
Hmm.
And that's usually only about 4 weeks, and then we're back to a build cycle, and that's where we're at today. So we're putting together our first production runs now, and we are getting ready to show them off next week. And then we've got several build cycles in queue, and we're going to have a lot of product here in a short amount of time.
With all the products that Impulse has helped design, there's always some kind of big challenge that comes up. What was the biggest challenge you and your team faced in developing this?
On this product, it was probably the most successful build I've ever had. But there's always challenges. There were some interface challenges. We have what we call a stabbing guide. So as your device is hanging from a crane and they're going to stab onto the device, the original one was a little too shallow and a little it just didn't quite solve the problem the way I had intended it to. And so in our testing and in our roadshow that we did, we observed that we needed to change how that interfaced with both the female adapter and then the latching mechanism itself. So those two elements changed significantly. And honestly, that was the biggest challenge we had in this design, was just making sure that that interface was really effective. I spent an extra, I think, 3 weeks just designing that interface and how the two, making sure that they can't get bound up or making sure they can't get hung up, and spent quite a bit of time on that one part just to make that interface right.
Interesting. If you could go back in time and change one thing about developing this product, what would it be?
How long it took?
Yeah,
I think, I think uh, as engineers, we're optimists, right? We always think we can do something in 2 weeks, and it never takes
sure.
2 weeks.
Yeah,
Um,
yeah,
I'll tell you every time, oh, yeah, I get that done in a couple weeks, no problem. And so something always pushes, but the timeline, I'd like to start rolling out products a little faster. And so as a design engineer and as somebody who's looking towards the future and start queuing up these designs and get them rolling out in a more timely manner, and in a little bit more systematically. But I think if I could shorten the timeline, I'd always shorten the timeline.
yeah, yeah. So, shifting gears a little bit, just kind of as we start to wrap up, what are some of the, I like this question just because everybody comes at it from a different perspective. So what are some of the trends that you see emerging in product development?
It's a great question. We have good tools for product development. I see the need for great tools, and I believe there are champions for great tools out there. I don't know if product dropping is can be useful here, but so as a developer, SolidWorks has been in the industry for years, and I've used it for more than 20 years. And then in 2018, I started using Onshape, and it's a tool that has helped me as a designer and a design engineer and a CAD manager manage the product life cycle or the product data, PDM, seamlessly. I don't have to worry about PDM anymore. So those type of tools, and they're integrating with Arena solutions for the PLM service and the QT, the quality product line that they offer there. I think if we can get a little more integration from CAD idea through purchasing and into the manufacturing shops and have a much more linear communications path through all of those. I've asked for it for years, honestly. Being able to have the machine shop generate the cam profiles and get the parts manufactured faster, without having to jump through all these extra hoops of translating and things, and it's coming. Oftentimes your machine shops now have the CAD tools at their hands, their fingertips, so they are bringing them directly in. They're bringing them from the CAD tool into the CAM softwares. But I think trending, I know there's several companies that are trying to make that transition from idea to product a lot more efficient, and I think 3D printing's helping that. Especially from a prototyping phase, but even some metal 3D printing that I'm seeing. So there's several companies out there developing high quality laser deposition 3D printing for metals. There's also the several other metal type 3D printers out there that are coming along. And so the trend to me is get it from this idea to in your hands, touching it faster. And there's lots and lots of people developing tools to get there.
Sure. Yeah. Yeah, that's interesting. I know you love Onshape, but it'll be interesting to see what they continue to add to that that product or
Yeah,
the ancillary services that are going to add on to it. So,
for sure. Yeah, Onshape's a small piece of that vision, but what they've done to allow multi people to be designing at the same time, having the system in the cloud where you can access it from your cell phone or your tablet, or I've seen people use refrigerator displays and actually log into to their Onshape account on a
wow.
refrigerator. So it's it's that functional.
Yeah, that's awesome. Yeah, and you were talking about, getting things more streamlined. I was just working on a design and it's got, I don't know, 50 or 60 parts in it, and I had to export everything in step or STL or both. And, I'm like, been doing this for 30 some years, and here we are still exporting every part individually and then pulling it back into another software. It'll be nice someday when we don't have to do that.
Yes, sir. There's a company called Topology that I've been working with recently, and they've got a different way of designing geometry with implicit models. And some of their implicits are now able to be brought into the EOS environment. And so that to me is a really fascinating trend for model transitions and going straight from idea to part.
Yeah.
Cool.
Yeah. Interesting. So reflecting on all the challenges, successes, and things you've encountered developing products, what words of wisdom would you want to share with those looking to make a significant impact in the product development world?
Yeah, if you're passionate about what you do, just do it. I try to mentor people and coach some of the younger people around me. Grab your goals, find your goals, grab them strategically, make them as effective as possible, and enjoy the ride, and you'll have success. I was lucky enough to get involved in CAD. I'm not trained in any specific discipline other than the tool. And so I've learned everything I've learned and done everything I've done because I know a good tool. Find your passion, follow it, and enjoy the ride.
Those are good words. Awesome. This has been great. Is there anything else you want to mention with regards to the product you talked about, or just product development in general?
Good question. Product development in general is an exciting field for me. Software, hardware, all these tools that we have today. I think there's a new shift in the tools that is coming that I think is going to be exciting times for new designers. And I think we still have to have the human overview and make sure that we're validating. I think there's a potential for a lot of products to be developed that are unsafe, and FHE being a safety company, that's really what we stand on, is safety. We want to make the best products in the market, and we want to make the locations safer. So we just got to make sure that when we're allowing the tool to do some of the development, we want to make sure that we're validating that before we just send it into harm's way.
Sure. So, excuse me, before we end, where can we find out more about the new product coming out?
Yeah, our website is builtbyfhe.com, and our web developer's done a great job. Go there and look at all of our products, safety products, and PCE equipment, things that we've done over the years, and go check us out.
So make sure that gets in the show notes. I really appreciate you doing this, Mathew.
My pleasure. Thanks for having me.
To learn more about Impulse and how we might be able to help you, visit impulseproductdevelopment.com.